In the last video, we looked at the myofilaments and how during contraction, the H zone between the thick and thin filaments, which we see right here, decreases during skeletal muscle contraction. So let's take a closer look at this and see how this is initiated. What we have here is a skeletal muscle fiber. This dip or invagination into the interior of the muscle fiber is known as a T-tubule. These undulations here are the junctional folds of the neuromuscular junction. Called that because this is a neuron, specifically a somatic motor neuron, that synapses with the skeletal muscle at the neuromuscular junction. In black here, these are just receptors for the signaling molecule or neurotransmitter that's going to be released by the somatic motor neuron. Notice that we have a polarized cell. That is to say, it's positive on the outside of the cell, negative on the inside of the cell. It's displaying a difference in voltage. I don't have the voltage written down here, but it's probably about -70 to -90 millivolts. Right in the middle here is the sarcoplasmic reticulum, which is the organelle that stores calcium. So all of these orange spheres represent calcium. This is a gate right here, known as the Ryanodine channel. Right here is a protein known as a DHP protein that is physically connected to this Ryanodine channel. If this somatic motor neuron depolarizes, it's going to release a neurotransmitter, which ultimately will result with the influx of sodium into the skeletal muscle fiber, causing a depolarization event. And here we see that DHP protein that's tethered to the gate, it pulls on that gate and allows calcium to leave the sarcoplasmic reticulum, bind to troponin, move tropomyosin out of the way, and then we get the sliding of the filaments and muscle contraction. Here you can see a diminished H zone versus the previous one. The H zone is much larger. So that is muscle contraction. What causes this somatic motor neuron to depolarize? It could be any number of things. It could be you wanting to lift a barbell. It could be you wanting to lift a glass of water. It could be wanting to lift up your arm and pet a sweet little puppy. Any number of things. It could be a reflex loop directly from your spinal cord. It could be some forethought from your cerebral cortex. But if this somatic motor neuron fires, releases its neurotransmitter, it's going to cause this cell to depolarize, open up the Ryanodine channel, allow calcium to be released, binding to troponin, liberating the myosin head binding site on the thin filaments, and we get muscle contraction.